All right, so welcome back. In this lesson, I'm just gonna teach you about operators. So these are your operators. We have and, or, and not. Basically, not is just talking about the opposite values. So I have right now robot set to true. If I say not robot, that means it would say false. So if this is true, it would say false. If this was false, it would say true. It's kind of the opposite. This is and is just like combining stuff. So if this is true and this is true, something might happen. So like let's say if robot and let's say this left claw is equal to 120, which is part of the previous code. If this was here and whatever code was under, since this is true, then we can display whatever code. So let's say, let me take a piece of this. We can, let's just say, for example, we can spin the claw reverse for that amount of degrees, for lift claw amount of degrees. And if it's false, that's why it's not going to activate anything. But if it's false, we can also have an else, which means if this isn't true, if the first part isn't true, then do this instead. So instead of this being true and it doesn't spin reverse, we can say else spin forward. If if like the first part is not considered true. And then ors are just like and, but instead of having both values be like having to be true, only one has to be true for in order to work. So if this was here, so if robot or lift claw was equal to 120, then this code would activate. Else, if they were both not on or they were both false, we would just have this the else activating. Then we have not, which I kind of went in depth into. So we can have not saying this. We can have not robot or this. So they would both have to be false in order for this first part to happen. Else this would play a part. Now for the elif, which is this thing, you can add this little plus sign just means you can add more ifs and else's if you want. But for now, I'm just going to be using the basic one, which is just one if, one elif, which is else if, and then else. So for this, we just have to say, let's just take this for example again. And then let's say we have to spin. That's gonna happen if that happens. Then we can take this out, right? We can reuse this, duplicate, and we could put this in here. And then if robot, and then we can just take this part out and we put it here, are true, then do this. Else, just print message one, which message one we said in the previous was stated it works. So that is a basic rough way on how booleans and operators work in Vex. In the real world, we kind of mostly use them to sort of state like loops and stuff like that. But overall, this is essentially what operators are mostly used for. All right, so I took the liberty of doing this off camera, but this is how you would implement these things in your code. So as you can see from the giant block mountain, whatever you want to call it, you can see there's a bunch of these loops. So there we have three right now. We have if and else, another if and else, and then this is an if elif else. So I decided to put this in, and this is just to go forward and do this. So if this is true, then it'll run this code. Else it'll run this code. It'll just go forward. And then I would run it again after this or whatever code has been ran. Go again, and then it checks again if this is here, and if it's not, it will go for another 200. And then for the final one, the reason I chose an LF was because we saw on the field that for this is like a distance of 500 all the way up to here, 560. You can kind of estimate that in 400 meters, you're not going to really see it. Sorry. In with this final stretch, you can see if robot, which is set to true all the way up here, if robot is set to true and distance in if object distance is equal to 50, let's actually change it to 100. Then drive forward to the object in distance, right? And then let me zoom in this part for you to make it easier to see. And then it'll run the same code essentially that I've been repeating. And if not, which is this, we drive forward 100 meters and then drive forward for 50 meters. And here we should have another one of these, like here. So we get this and we duplicate this and we stick it down here just in case. So our code is looking real lengthy. At the bottom we should just have this. So all this code is simply doing is using a distance sensor that I plugged in. So for here, this is just distance, and this is just telling us how far the little pins are on the field. So this pin could be 560. So we're just going closer. We're cutting it, like estimating slowly, like pretend these black lines are like where our position as a robot would be as we travel 200 meters. So we get closer, we go up to the first line, we check, then up to the second line, we check, and up to the third line, we check again before running the rest of the code. That is basically what this giant piece of code does. Here in Python, you can see all the else ifs. So basically, when you do a regular defining thing, which is this little block up here, the when started is defining a function. It always indents, and for every if and else, you can see that there's like some extra indentation. When you do an else or an if or a if else, you have to put extra indentations to show that this is part of the if and not just part of the regular function itself. And same thing works with C++. You also have to indent. It works in every program. Every program you have to have an indent to show that it's not only just part of the function, but it's also part of the if or the else or the elif in this case. So right here you could see if, and there's a giant indent, and there's here this ends. When you have an if or an else or an elif, you have to have these brackets that also represent the end in C++ that start and end a function, which is our if. Our if is like our little mini function in a way. So is our else and our elif, which is down here. This just opens and closes the function, just for your information. And that's pretty much just how if and else's work really. This I'll show you in the next section how to make this way smaller and way cleaner cut. But for now, this is how you would really implement your if and else structures into your code as you're driving on the field.